Hello students, welcome to the third lecture on the lecture series on integers and whole numbers. So previously we have discussed what integer is, what whole number is, and we have discussed all the basic type of concepts and types of problems that are usually involved in various competitive exams in this topic, integers and whole numbers. So what we will do in this lecture, okay? So we will be actually covering some exercise problems so that the concepts that you have already learned, you can actually apply those to actual real life problems, okay? So that what you can do is you can keep all those concepts to your head, okay? So let's go forward and start the lecture. So this will be the third lecture in the lecture series and we will be covering exercise problems. So let's start from problem number 1. So it tells us that simplify the expression 4 multiplied by 15 minus 3 plus 10 by 2, okay? So this is a mathematical expression or numerical expression that we need to simplify. So how we can simplify this? We can actually use BODMAS rule, okay? So BODMAS rule. So let's first learn what BODMAS rule is. So in BODMAS, B stands for brackets, okay? And O stands for exponents, and D stands for division, and M stands for what? Multiplication, and A stands for addition, and S stands for subtraction, okay? So this is what BODMAS rule is, okay? So in this expression, what we will try to see is how we can apply BODMAS rule. So how to use BODMAS rule in this? So BODMAS rule, right? So we want to apply this rule. So first we look for brackets. Are there any? Yes, there are brackets. So what do we need to do? We need to simplify the numerical term inside that bracket, okay? Then inside the bracket we are seeing multiple numbers and operations. So how we'll proceed? We'll look again for brackets. Are there any? No. Exponents? No. Divisions? No. Multiplication? No. Addition? No. But there is subtraction, okay? So we can subtract this. So the expression from this, that is 4 into 15 minus 3 plus 10 by 2, okay? So after step 1, what it will be equal to is 4 into 15 minus 3 is equal to 12 plus 10 by 2, okay? So let's go forward. So we have solved the bracket issue. Now we are going for exponents. Are there any? No. 4 power 1, 12 power 1, 10 power 1, 2 power 1. So there are no exponents, okay? So let's try to see for divisions. Are there any? Yes, 10 divided by 2, okay? So we need to solve this first. So next simplify this. 4 multiplied by 12 plus 10 by 2 is equal to what? 5, right? So we have also solved this. That is the division issue. Then we are having multiplication, okay? So we need to see, are there any multiplication involved in this numerical expression? So yes, there is a multiplication involved. So what we will do is we will simplify it. So 4 into 12 is equal to what? 48 plus 5, okay? So we have also solved the multiplication issue. Now we are going for what? Addition issue, okay? So are there any addition? So yes, since there is a addition, so it will be equal to what? 53, okay? So since after 53 there are no mathematical operations left, so we'll pause it right here. That is in the BODMAS at addition, okay? So the answer will be 53, okay? So let's go forward and see the step-by-step solution. So step 1 is to what? Solve for the bracket using from BODMAS rule, right? From BODMAS rule, we go for bracket first, okay? So then what we do? We multiply it by 12 and then what? So the remaining 15 minus 3 comes to 12, right? So solve for the fraction part and multiplication part. So first fraction part, because for BODMAS, after exponent, since there are none, we go for division, right? So that's why we are solving for the fraction part, that is 10 by 2 is equal to what? 5, right? So then what we do? We go for the multiplication part, because after division, there is the multiplication that needs to be simplified. And then we go for addition, as 48 plus 5 is equal to 53. So since we have evaluated here and we have gone for a step-by-step solution here, as you can see, both the solutions are same because the methods are all correct, just the approaches are different, okay? So in both approaches, actually BODMAS rule is applied, okay? So let's go forward and see problem number 2. So solve for x when x is given in this equation, mathematical expression or equation. So it is what? X plus 5 is equal to 70. So how you will go forward and solve this? So there is a quantity in the left hand side which is added to 5 and what it returns is 70. So what we can do? We can subtract in both the sides. So x plus 5 minus 5. is equal to what? 17 minus 5. We can write this. So now applying Budma's rule in the left and right, what we are left with is this imply that x plus 0 is equal to what? 17 minus 5 is equal to what? It is 12, right? So this implies that x is equal to 12. Okay. So for this question, the answer will be x is equal to 12. So let's go forward and see the step-by-step solution. So subtract 5 from both the sides. So subtracting 5 from here and 5 from here. So what we are left with is x plus 0 is equal to 17 minus 5. That is equal to 12, right? So this implies that x is equal to 12. So let's go forward with problem number 3. So solve for z when the given mathematical equation is what? 3z plus 7 is equal to 22 minus 5z. Okay. So what we need to do? Okay. So first we need to do what? We need to keep all the unknown variables to one side of the equation. Okay. So let's try to take the unknown variable to the left hand side. Okay. That is the standard form. So you can do it. Or else you can also take what? The unknowns to the right hand side. There is no problem. But just for what? Visual aesthetic recommendations, we can do what? Keep all the unknowns in the left side. So this will be equal to what? So this implies that. So how we can convert this unknown variable from here to there? So we'll add something here so that the unknown variable part becomes 0. So 3z plus 7 plus 5z is equal to what? 22 minus 5z plus 5z, right? So we can cancel these two terms out. So it will be 22. So this implies that it will be what? 8z plus 7 is equal to 22, right? So what will happen next? So we need to make the left hand side only consisting of what? A known variable. So this will imply what? So 8z plus 7 minus 7 is equal to 22 minus 7. We subtracted 7 from left and right side both. So it will be equal to 8z is equal to what? So it will be 7 minus 7 is equal to 0. So it will be 8z is equal to 22 minus 7. That will be 15. So this implies that what? Z is equal to 15 by 8, right? So this must be the correct answer. So let's go forward and see the step-by-step solution. So step number 1 is what? Adding 5z to both the sides to make the unknown variable only on the left hand side. So here we added it and here we also added it. So these two what? Cumulatively give 0. So this is the equation we are left with. Okay. So subtracting 7 from both the sides, we are left with what? Only unknown variable with its coefficient in the left and some known value in the right. Okay. So now divide 8 by both sides and it will be giving us what? Z is equal to 15 by 8. So this will be the correct answer in this case. Let's go forward with problem number 4. So if the sum of 3 consecutive even numbers or integers is what? 114, then what is the largest of these integers? Okay. So let the first integer is what? Z. Okay. So let the first integer is what? Z. And it is actually positive. Okay. Actually, it need not be positive. Okay. Let the 3 integers be what? 2z, where z is some natural number. And the next integer will be what? 2z plus 2, right? And the next one will be 2z plus 4. That is this much plus 2. So this will be equal to what? So let's try to sum these up. So this implies that adding all these stuff, so it will be 6z plus 6 is equal to 114. So this implies that 6z is equal to 114 minus 6. That will be equal to what? 108. So this implies that what? Z will be 108 by 6, right? So this will be equal to 54 by 3. So how it can be converted to a single value? So it is what? 18 into 3 by 3, right? So you can cancel 3 out from numerator and denominator. What we are left with is 18. So the even number will be, so 2z will be what? 18 into 2, right? And 2z plus 2 is equal to, this will be what? 36, right? This will be 36, so this will be 38. And 2z, so 2z plus 4 is equal to what? 2z plus 4 is equal to 40, right? So summing these 3 up, what we are left with is 114. Because 40 plus 30 plus 30, that is 60, is equal to what? 100. And 8 plus 6 is equal to 14. So the cumulative will be what? The cumulative value will be 114. If we add these up. Okay. So the first number is what? 36. The second continuous even number will be 38. and the next one will be 40. Okay, and summing these up, we are left with 114. So let's go forward and see the step-by-step solution. So let's assume the three consecutive even numbers x, x plus 2 and x plus 4, and even integers increase by 2 each time, right? So according to the problem, their sum is what? 114. So x plus 2 plus x plus 4 is equal to what? 114. So combining like terms, 3x plus 6 is equal to 114. So subtracting 6 from each side, 3x is equal to 108. So dividing each side by 3, x is equal to what? 36. So three consecutive even numbers are 36, 38 and 40. So the largest integer is what? 40. Let's see problem number 5. So if an integer n, when divided by what? 4, gives a quotient of 21 and remainder of 3, what is the value of n? Okay, so given that integer n when divided by 4 gives a quotient of 21 and a remainder of 3. Okay, so what is the value of n? So given that n is equal to what? D into q plus r, because what? So when an integer is divided, the relationship between quotient, divisor and remainder is what? This, given by this expression. So given that d is equal to 4, q is equal to 21, r is equal to 3. So n will be what? 4 into 21 plus 3. So this will be equal to what? 84 plus 3 is equal to 87. So the correct answer will be 87. Let's go forward with problem number 6. So the product of two integers is what? 1000 rupees or 1000. So if one of the integers is minus 10, then what is the other integer? Okay, so what we need to do is, so given that a into b is equal to 1000, so we can guarantee that a is not equal to 0 and b is not equal to 0. So we can directly discard what? A, b are not equal to 0. But given that a is equal to minus 10, that is what given, right? Minus 10. So what will be the value of b? So b into minus 10 is equal to 1000, right? So this implies that b is equal to minus of 1000 by 10. So cancelling a 0 out, what we are left with is minus 100. Okay, so b must be, that is the other integer must be minus 100, so that their multiplication becomes what? 1000. So let's see the step-by-step solution. So let's call the other integer as a, given that minus 10a is equal to what? 1000. So to find a, divide both the sides by minus 10. So a will be equal to minus 100. Okay, so here another approach is maintained, but they both give the same result. So the other integer is what? Minus 100. So if the average of 5 consecutive odd numbers is what? 25, then what is the difference between the largest and the smallest of these integers? So let's assume the 5 consecutive odd integers as x, x plus 2, x plus 4, x plus 6, x plus 8. Odd integers increase by 2 each time, right? So according to the problem, the average is what? 25. So what? So adding these terms and dividing by this much, it gives us the mean. So that will be 25 by 5. So 5x plus 20 is equal to 125. We have to solve this one. So subtracting 20 from each side, we are left with what? 5x is equal to 105. So dividing by 5, we are left with x is equal to 21. So the 5 consecutive odd numbers integers are 21, 23, 25, 27 and 29. So the difference between the largest and the smallest will be what? 29 minus 21, that will be of 8. Let's go forward with problem number 8. Okay, so a certain integer is squared and then increased by 16 to give a result of 1092. Then what is the integer? Okay, so let the integer be x. So it is squared. So x square and increased by 16. Okay, so given that x square plus 16 is equal to 1092. So this implies that x square is equal to what? 1092 minus 16. So it will be equal to what? So it will be 1. It won't be 1. Yeah, it will be 1076. Okay, so that will be the value 1076. Okay, will be x square's value. So this implies that x is equal to square root of plus or minus 1076. Okay, so c square plus 16 is equal to this much, so c square is equal to this much. So the factors of 1076 are the squares of the integer 484 and 4, because 22 square is equal to 484 and 2 square is equal to 4. So c will be what? 484 is equal to 22, or c will be equal to minus 22. So therefore the integer c could be 22 or minus 22. Okay, so let's see problem number 9. So what comes next in the sequence? 6, 13, 24, 39, 58. and so on. Okay, so as you can see here, what we are doing is, given that sequence is, so difference between them, that is the consecutive terms, is what? 13 minus 6 is equal to 7, 24 minus 13 is equal to 11, 39 minus 24 is equal to 15, 58 minus 39 is equal to 19. So difference between the consecutive terms are increasing by 4 each time. So continuing the pattern, next difference should be what? 19 plus 4 is equal to 23. So adding the difference to the task last term, that is 58 plus 23 is equal to 81. So the next term in the sequence would be 81. So find the difference for the term after the difference for the term after 81 should be 23 plus 4 plus 27. So continuing the pattern, what are left with is 81 plus 27 is equal to 108. Now we have the next term, which is 108. So putting all the together, we complete the sequence as this. That is 6, 13, 24, 39, 58, 81 and 108. Let's see problem number 10. So what comes next in the sequence is 4, 9, 16, 25, 36. So the next one will be 49. So you must be wondering how. And the next one will be 64. 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square. Okay. So let's see the step-by-step solution. So given the sequence 4, 9, 16, 24, 25, 30. So we need to identify the pattern and the next terms in the sequence. It appears that this sequence represents the squares of consecutive positive numbers. Okay. So the first term is what? 2 square is equal to 4, 3 square is equal to 9, 4 square is equal to 16, 5 square is equal to 25, 6 square is equal to 36. So the pattern is that each term is square of the next positive integer. Continuing this pattern, the sixth term is what? 7 square is equal to 49. So the seventh term will be 82 is equal to 64. So the completed sequence will be 4, 9, 16, 25, 36, 49 and 64. So what comes next in the sequence? That is 50, 46, 30, 42, 41, 40. So let's go forward and see the solution. So at first glance, it might not be immediately clear what to do. So let's try to solve it. So 50 minus 46 is equal to 4, 46 minus 43 is equal to 3, 43 minus 41 is equal to 2, 41 minus 40 is equal to 1. So it seems the difference between the consecutive terms are decreasing by 1 each time. Based on this pattern, we can continue. So 40 minus 40 will be at 0. So the completed sequence will be 50, 46, 42, 41, 40, 40. So let's see problem number 12. So each sequence begins with 3 and 7. So each subsequent number of sequence is the sum of the two preceding numbers. So what is the fifth number in that sequence? So the sequence is what? 3, 7, 3 plus 7 equal to 10, 7 plus 10 is equal to 17, 10 plus 17 is equal to 27. So the fifth number in the sequence is what? 27. Let's see problem number 13. So find the 10th term in the arithmetic sequence where the first term is 5, common difference is 3. So for an arithmetic sequence, nth term is equal to what? First term plus n minus 1 into x, that is potential common difference. Okay, so plugging in the values. So we are left with what? 5 plus 10 minus 1 is equal into 3. So 5 plus 27 is equal to 32. So the 10th term is 32. So problem number 14. So in a geometric sequence, the first term is 4 and the second term is 12. What is the fourth term? So for a geometric sequence, nth term is equal to what? First term into common ratio power n minus 1. So from the given terms, the common ratio r can be found as what? Second term by first term. This implies 12 by 4 is equal to 3. So plugging in the given values, so fourth term is equal to what? 4 into 3 square, 3 cube. This implies 4 into 27 is equal to 108. So the fourth term is 108. Let's see problem number 15. So the first two terms of a sequence are 5 and 7. Each subsequent term is the difference of two preceding term. Then what is the seventh term? 5, 7, 7 minus 5 is equal to 2, 7 minus 5 is equal to 5, 7 minus 2 is equal to 5. So 2 minus 5 is equal to minus 3. 5 minus minus 3 is equal to 8. 8. So minus 3 minus 8 is equal to minus 11. So the seventh term of the sequence is minus 11. So problem number 16. A series start with 8 and each subsequent number is 3 less than the previous number. What is the sum of the first 7 terms of this series? Okay, so this is an arithmetic series with the first term being 8 and the common difference being minus 3. So the seventh term is equal to what? 8 plus 7 minus 1 into minus 3 is equal to 8 minus 18 is equal to minus 10. So the sum of first 7 terms in the arithmetic sequence is what? Sum of 7 terms is equal to this. So it will be minus 7. So the sum of the first 7 terms of the series is what? Minus 7. Let's go forward with problem number 17. So is 777 divisible by 4? No. So you must be wondering why. So we'll learn actually the concept in relationship between number, but let me tell you right here. So a number is actually divisible by 4 only when its last two digit divides. So 4 divides the last two digits of it. Since 4 does not divide 77, so it can never be bought for, but or it can never be divisible by 4. So to determine a number is divisible by 4, you need to check whether the last two digits of the number form a multiple of 4 or not. So in this case, this one. So actually this will be wrong. Okay. So there are, it is not divisible. Okay. So since 77 is not a multiple of 4, so 777 is not divisible by 4. So find the remainder when this is divided by 11. Okay. So to find the remainder, this when divided by 11, we can define the divisible rule for what 11. So according to the rule, a number is divisible by 11 if both the difference between the sum and alternating digits of the sum, its remaining digits, is either 0 or a multiple of 11. So let's break down the number 1, 2, 3, 4, 5. So 1 plus 3 plus 5 is equal to 9. 2 plus 4 is equal to 6. So 9 minus 6 is equal to 3. Since 3 is not divisible by 11, this means this is not divided by 11. So is 2, 3, 4, 5 divisible by 3? Okay. So to determine if a number is divisible by 3, you need to check whether the sum of the digits is divisible by 3. So in this case, it is 5 plus 4 is equal to 9 plus 3 is equal to what? 12 plus 2 is equal to 14. So no, in this case, it will not be. So let's apply this rule to the number 2, 3, 4, 5. That is 2, 3, 4, 5 is equal to 14, right? So since 14 is not divisible by 3, it leaves a remainder of 2 when divided by 3. So the number, this is not divisible by 3. Okay. So by doing all this, we have done a variety of problems on integers and whole numbers. So I think it would be enough for you, okay, for today, to complete all these problems again for you. Okay. So thank you.